Hey guys, welcome to my channel, Design with Ruzbe. Today I want to talk about question 1.1 from CSWA practice problems. Basically my goal is to go through all of these questions, not only this one, but also other questions in the problem set that we have from SolidWorks, and share my thoughts with you. Basically I want to show you how I approach each of these questions and highlight the challenges you might face when you're solving these questions. Before I start, I want to highlight an important point here. Each person can have their own approach to model a part. So eventually, you are the one who needs to choose the best solution which works best for you. You don't necessarily need to follow what I'm doing here. What I'm presenting here is the method that works best for me. So if you have any comment, if you have any other approach, feel free to share with me. I would be happy to see other approaches as well. And as an example, I'm going to show you two different approaches for question 1.1, and you can choose eventually which one works best for you. With this introduction, let's go and check this problem. Question 1.1. The first and the most important thing in every question that you see is unit of measurement. Here, unit of measurement is millimeter gram second. Now the question is, how can you set this? If you go to SolidWorks, on the right corner, you see that there's a drop-down menu, and then from this you can choose unit of measurement. It's important to have the correct unit of measurement, and I chose millimeter gram second. Now let's go back to the question. In this question, we want to model this part, and the way I want to model it, I want to start from the front view. In this view, you see that we have a sketch, we have couple of dimensions that we can use to model the part. So let's do that. So for this, I go to a sketch tab, and then from here I choose a sketch. Then I go to the front plane, and here I need to draw a 2D sketch. You don't need to be really accurate, just draw something which is kind of similar to this view. Then we are going to dimension the part. So I'm going to draw something like this. So let's do it. From here I go to the right, then here, then here, 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 this one, this, and this. Something like this. Doesn't need to be super accurate. I'm just drawing something close to what I see on a drawing. Now we also need a circle here. Now we start dimensioning this part. So what do we have? We have 75 millimeter for this. We have 60 millimeter for this one. We know the distance of center of this circle, and the wall is 16 millimeter. Same distance for this, 16, and then the diameter of this should be 12 millimeter. Next step, this one should be 12. Also, the distance between this wall and this wall needs to be 20. And finally, this one needs to be 30. Okay, so basically I used every dimension that I have here, but as you can see, the geometry is not fully constrained. How can you say that? The answer would be the color of these lines. You see, we see two different colors. When it's black, that means that the line is fully defined, but when it's blue, that means the geometry or 2D sketch is not fully defined. In other words, you can move the geometry basically, and I'm going to show you here. You see, I can easily move it. Why is it important to have a fully constrained geometry? The reason is, in the exam, sometimes they ask you to change one of these parameters. Let's say they're asking you to do the measurement for this part, and then in section B of the question, they're going to ask you to change 75 to 100. If your geometry is not fully constrained or fully defined, when you change 75 to 100, you will see some sort of explosion in your geometry. Everything will kind of fall apart. That's why it's important to have a fully constrained geometry. So now how can we make this geometry fully constrained? If you look at the 2D sketch, you see from top view we have 3 other dimensions: 20, 12, 12. These are kind of defining the widths of the features. So I'm going to use these dimensions. So I'm going to set this one like 20. This one should be 12. And this one should be 12. Now you can see the geometry is fully defined. Everything is black, and it's great. It's ready for the extrusion. Now here I choose to add 3 more lines. I will explain for you why. I'm gonna add a line like this here. I'm gonna add another line here. Oh, sorry, this should be horizontal. Okay. And I'm gonna draw another line here. It's just a line. And now I'm gonna extrude this feature. How can I extrude this? You simply go to the feature, you click on extruded bus, and SolidWorks asks you what contour do you want to choose. By adding those lines, now I'm able to choose different contours, whatever contour I want. So first, I'm gonna start with the bottom one. What's the thickness that I want? It should be 28. Why 28? Because on the top view, you see this dimension is 28. So I go back, and this should be 28. Okay, first part done. Now I want to do another extrusion for the rest of the contours. So I click on extruded bus, and you don't need to draw 2D sketch again. You can use the previous sketch. So just click on model tree, go to bus extrude, and click on the previous sketch. The sketch is now active. What you can do, you can select other contours, but this time I'm gonna extrude this for 20 millimeter. And done. So basically now I have the final geometry, and this is what I wanted to have. Now how can we ensure that this is the correct geometry? When you're solving this problem, you see that on the right side they gave us the total volume that we should expect for this part. So it's 72,593. So how can we find the overall volume? To do that, just click on evaluate here, evaluate tab, and go to mass properties. And here for the mass properties, you see volume is equal to 72,593. So we found the correct answer, or in other words, our modeling was correct. So this is one approach. I just want to show you one approach to complete this modeling. Now, as I said, there could be different approaches. So what's the second approach? I want to show you a second approach, how I am modeling this part. So let's delete these features. When you delete the features, don't worry, the sketch is still there. So when I delete the feature, you see the sketch is there. So what I'm gonna do, I'm gonna use extruded bus, and I select everything basically. Imagine these were not the separate contours, it was just one contour. So I'm gonna extrude everything for 28 millimeter. What I can do this time, I can sketch a 2D geometry on the right plane. I'm gonna make something like this, and I'm gonna set this distance as 20. And what I'm gonna do, I'm gonna use this 2D sketch combined with extruded cut. I'm gonna cut part of the solid geometry that I have here. So I click on extruded cut, I change the direction, and I change this one to through all, which means that this cut extrusion process will cut everything in a solid geometry. And here we are. So you see, we got the same result. Now, in order to make sure that this is correct, I click on evaluate, I go to volume, and you see the total volume is 72,593. So the answer is correct. Okay, that's it. I hope you enjoyed this video. If you have any feedback, any question, please leave comment. And thanks for watching. Again, my name is Ruzbe. Hope to see you again soon in the next videos.